let's see what this does. Right, okay, that looks to run. Let me take the audio. Hello, everybody. Okay, audio seems fine. So yeah, let's continue where we left off, where we headed up last time. Right, so we're doing spatial partitioning. Right. Where was I? Sorry. Yeah, right. So we were trying to make a BVH. Although I have been considering maybe putting the BVH on hold. I'd rather go with a scene structure. But again, to make a proper scene, I kinda want a BVH. So I think it would be good to continue working on this. Because I need to get this done anyway. I do actually kind of need the other Visual Studio project open with my old Raytracer. What's going to be useful? There we go. And this is just for me to glance at some information if I need it. Because I built a BVH before, and it's good to have some references how I've done it before. Right, so first of all, for the BVH, I think for now, because we basically build our world with models instead of primitives like I did in the old Raytracer, because the overhead of, what do you call it, having primitive virtual functions is kind of unnecessary, because we can do everything with models, and with spatial partitioning, the cost of models will be drastically reduced, so I think that's going to be fine. So I think we can assume that we, in a model, always have enough triangles to actually be worth it to build a BVH. Because otherwise it doesn't make sense to build this BVH. The only reason I can see it is for this one, this overload, because we pass in basically all the models in the scene to be BVH. But if there's only one model, we don't really need BVH. So I think we can just continue with this function and worry about the other one later. No, I think I'm actually going to do something different. Does the model have the ability to... Oh, just literally a struct, right? So in that case, I don't pass in this. I rather pass in a const RT model reference model. Right. Because it's going to be a bit... Oh, I accidentally commented out the const... Oh, whoa. Right, there we go. Yeah, that's good, that's good. And then it's model.triangles. Right. Because it doesn't really make sense to pass in the triangles. I think it's more logical if we just say, hey, this is the model that we want to render, or PVH. Oh, yeah, right. So next up, yeah, we don't need to sort anything like I did in the old one. So in the old one, I had to sort shapes because I had, for example, planes in there. You can't put a bounding box around, well, planes because they're infinite by definition. So I can skip that. So this is the old code, right? I don't think I need to allocate boxes because if I remember correct, did I actually make the model contain... I'm now beginning to doubt. Yeah, thank you, Jinx. You too. Have a Merry Christmas. Or Christmas, actually. Wait, did I put it in? Where did I put the cat? Where did I put a model? No. Control T. RT model. There we go. No, it's just a struct, right? But I did have the ability to get one around here. No. Oh, no. I didn't want to run the Raytracer. What are we doing? No, I didn't want to debug. Right, so the model doesn't have the ability to generate a bounding box. That's fine. Or doesn't have bounding box. Right, cool. So we do need to allocate a bounding box then. Oh, wait, yeah, I remember. Right, yeah. I generated notes here, sure. So in the old Raytracer, what is an ABB box? Is it just the floats? Yeah, cool. Okay, right. Um, so we do need to allocate PVH nodes, but I think we already did that, right? In here, because this is the nodes. All right, cool. Sure, that's fine. Um, then I think we want to, yeah. So we need a bounding box of the shape, right? Of the model itself. What is important? So in case you didn't know, right, a PVH is very simple. So let's say we have a bunch of shapes here, right? The root node starts out with placing a big box around all of them. Then then we put a box around other shapes, and then, for example, one more here. And this basically now allows you to traverse through the structure and find the actual closest shape that you intersected with, but can speed up things a lot. So instead of doing 5 tests now for in this small example, we have to do at worst 1, 2, 3, 4, 5, 6. Well, I mean, it's not ideal, but a small number makes this not very optimal. But in case you have hundreds, you can knock off basically 50% every time, what can speed up things very drastically. Right, so for the model, yeah, let me open it up again. Right, so we want a simple function that returns glm vec3 no yeah, it's an array of 2 cat bounds. But I think it would actually be right. No, we can expand this a little bit. So we can simply store the glm vec3 at size 2. It's the same as before, but whatever. M dot bounds. Oh, right. So when we actually load in the model, we can calculate this. Because the bounds are going to be the same, however the model is, right? Because the bounds are an abstract thing. It basically contains all the triangles. Even if you scale the model, right, the actual triangles still stay the same. You change the transform, and the transform changes the ray that actually creates the effect. So this bounds is basically just a variable that says, hey, all the vertices fit in this compartment. So in the obj loader, when we load in the model, right, right, so this is the vertices. Right, cool. Right, and then we need right, cool. So we have the vertices here. Let's make a temporary glm vec3 called vertex, and we initialize this with these values. And then we pass in a vertex here. Or we pass in the vertex. And then we do this, right? Did I? No, I didn't. Wait, what? Oh, no, 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 no. Right. What am I doing? No, this is oh no, this is stupid. Right, yeah. So I forgot it's already a GLM factory, because we recreated them here, right? That was stupid. Right, yeah, sorry. Yeah. So we can just simply go over this. So model. I think I can simply do. I do actually need to go into model and set these values. So bounds equals. So it's minus infinity. I do need floating point infinity. Floating point. Yeah, FP infinite. I think I can just do, yeah, so minus. No, sorry, this should be positive. FP infinite and FP infinite. And then minus FP infinite minus FP infinite. And minus FP infinite. Although I might have to swap these at x's because yeah, no, I have to swap them, right, I think. Because the negative z-axis points. Wait, let me double check. So the model is at 0, 0. So it's in the main that I set up the camera. Okay. So the camera is, yeah, -5 is into the screen. Right, yeah. And 10 is towards us. Cool. So I do think we need to swap this. Yeah, sure. Let's just try this and see what happens once we load in the model. So model 0 equals GLM. I think we could do min. I remember there's some GLM function for this. GLM. I'm pretty sure we can. Right, yeah, there is actually a component min. Cool. From the minimum value between single vector components. Right, but this just returns a single value, what isn't great. But I think the regular min does actually work. So model.0 and then we need to copy this, and that's +1 and +2. Right, why is this complaining? Oh, yeah, of course. Model.bounds. Right, this is not the prettiest code because we're duplicating a lot of code, but I think it's fine. Otherwise, we're gonna have to do another loop, and it's kind of a pain. Because we'd have to do a double nested loop to loop over like 3 vertices to, yeah, I don't think it's worth it. Right, cool. So let's just run this and see what the model actually gives us. Right, cool. So the model bounds pointer bounds. Right, so that's -4, -3 on the y, yeah, and minus in that direction, cool. And this is, so let me think about this, right? So no, actually no, we did swap these axes in the wrong way, because I want basically the min to be the bottom left and max the bottom right. So yeah, we do need to actually change this. So this should be positive and this should be negative as well. I think now it should give us the correct value. I think. Uh, negative, negative, negative. That's sure. Positive, positive, in front. Yeah, sorry. Yeah, this is correct. So the left is all the minimum is all the way in the back, and positive is all the way in the front. Sure. We at least have now a minimum and a maximum. That makes sense, I think. I hope that makes sense at least for you guys. So now we know for sure, right, that within these two values, all the vertices of the model are contained in here. What is very important to know. So we can basically say in this box we know for sure that all the models are here. So now we can simply, and we go back to our painting. Let's say this is our model, right? We have now a box around it that says, hey, all the triangles are in here, in this box. Right. So now in the BVH, we can simply say, no, actually, we're going to need another function, because now we actually start partitioning the data. So I think we want a function here called void partition that takes in a const std vector of no, this just takes in a model as well. Right. So the idea for this is that we partition data to work on it. So now we have the number of nodes in the constructor. Then we want to partition the data. And I think we're going to need an offset here as well. So, do we? I'm thinking, right, what's good, because we kind of are dealing with two different concepts here in one BVH that we're trying to merge. So we want to be able to build a BVH from a model, a bounding volume hierarchy. So we pass in a model and it subdivides all the triangles. We also want to basically be able to pass in a bunch of models and have the domain of the model be partitioned, right? So the model BVH is basically this part where each model is being contained, so we can quickly find which model we intersect. So this will allow us to have thousands of models, but then we want BVH as well that subdivides the actual model, the actual triangles. Although, do we want to simply merge them? I don't think we want to. Because they fundamentally do something different. They intersect with the scene. Because they both reverse the same, they just return a pointer. I'm thinking what's good. Yeah, you know what? I think for now, I can just work on the single BVH for the model, from there we can see what they're seeing. I think that's going to be a bit easier because I think doing everything at once is just going to confuse me massively. Right. So we can just minimize this. Cool. Right. So m dot nodes dot 0 equals this is not that. This is dot bounds. Can we simply do the following? Model dot bounds. I think. Does that work? No, that doesn't work. That's a shame. That's an actual shame. But we can change this because what we can do is actually make it an array. Although that might. No, I think actually the array should be fine actually. So if we, although I do kind of like the C array because it's very clear what the size is going to be. What I think is important because this is aligned for CPU lines, and if the array by any chance does something odd, it might be a problem. Although I think it should be fine, the STD array. Yeah, let's just STD array float going to right bounds. Cool. And then in the model, if we still let it open, yeah. Oh no. Oh, right, this should be a GLM vector3. Sorry, not floats. And then include array. And there should be a GLM vector3 then. Right. Yeah, cool, that works. So then we do need to go back to BVH node and no, sorry, BVH node. And should just do a GLM vector3. And of course it's complaining because this is called bounds. Yeah, right. So we can simply assign them now because the vectors do actually, or the arrays do support copy instead of the CRAs. What? Great. All right. Yeah. That's good. We now have the nodes, and then right. BVH node. What is this? This should be. This can be default initialized to 0 and 0. Then in the BVH, so m.nodes.0 equals model.triangles.size and m.nodes.0 dot count. I think left can be empty actually. Right. Cool. And now we do need a subdivided function. Right, so this sets up the. Oh, you know what? Actually, can the uint 32. That's actually a bit more specific. No, sorry, int. No, this can just be an uint. Yeah. Because it's A16 is 2, 32. Yeah. So now we can be a bit more specific on the actual size. because now we specifically say, hey, we want a 32-bit number, so 4 bytes. A bit better than just regular ints. I should get in the habit of that. Right, I'll just explicitly actually do set the left here to be 0. Right. Then we do want a void divide that takes in a RT BVH node, reference current node, I think, current node, and a UN32 left. Right, and generate implementation. But now we can simply call subdivide. M dot nodes dot 0 and 0. Right. So basically what we did now, right? We set up the first, the root node that contains the shape. So we now know, hey, right, so the root node is the bounds of the model. It has this number of triangles, and it starts in the triangle array 0. So it contains all the shapes from 0 to the number of shapes here. Right, so now the subdivide. What's the subdivide going to do? Right. There are multiple ways to approach the BVH. One of them being simply saying, hey, if we have like 3 models left, you just don't subdivide anymore. Or you can do something called surface area heuristics, which basically we analyze the surface and see what is the smallest possible area, and if the subdivide is bigger in area than the original, yeah, you should terminate. So I think I'm actually going with that approach instead of the simple split I used in the old one, especially since the BVH of a model we can make it expensive to make, because if we just say, hey, we don't support, for example, animations, the model will never change. It can move around, that's fine. The BVH will still stay the same. Even with rotation, the BVH stays the same. In animations, things are going to be different. I think we can make that sacrifice to go with a bit more expensive subdivide algorithm that gives us better performance. I think that's fine. Right. So we need some sort of escape here. So to do escape, right? We do actually need to know which pool points we're actually working at. So I think we need to pass that in here as well. I think we could just make this a static variable. Do we want that? Yes. So we don't want that. Right, so the subdivide takes in the a UN32 reference pool pointer. Right. No, I don't want to print. Thank you. Subdivide. Right. And then we create a UN32 pool pointer, and this is equal to 1. Right. Because we already set the first pool here. Right. So it's 0 or it's 1 since we set the root node, and this basically just is an index to the array of node, so we know which node to access. Right. Right, so we know now, right? So the current node dot left equals pool pointer. Yeah, and we want to do this plus. So we're basically saying, hey, right. So each node has two children, one on the left, one on the right, that contains another bounding box. So we're basically saying, hey, this node, the first child equals the second index, and then we want to add one. And then we simply want to add one again, because we explicitly know, right? If the node on the left is index 1 in the array, then the right node is x is 2. And then we need to add one more because we already set that pointer, right? Right. So now we set up the children node, so we reserve their space. And let's set up a define here. I think let's actually do it in the header. So hashtag define num of splits. I think something like 16 should be fine. So this will give us calculator 16 times 16 times 16, like 4,000 tests that we need to run. No, less, way less. Whoa, what am I saying? It's 48 tests. No, yeah, 48 tests, right? Because we're basically splitting along different axes and seeing, hey, which actually. So this is a method called binning. I'm sorry for rambling on here. Let me show binning. So let me see if I can find a good example on Google. No, not really. Right. So the basic idea of binning is quite simple, right? We need to know basically we need to subdivide the model, or we need some sort of access to split the models along. We could simply test every possible split by knowing where the objects are and basically saying, hey, we can split them along this, but this can be quite expensive. So what we can simply do is say, hey, we have all these models. We simply check 16 axes on the X, Y, and Z and see which one is the best. It's not as good as checking every possible method, but 16 possibilities gives us a pretty decent estimate of what the most optimal one is. It's like, imagine pi, right? You with the binning method, you would get the answer 3.17. But with the actual method, you would get like 7 digits of precision. But 3.17 is plenty for a lot of applications. It's a bit of a bad example, but right. Why is it still complaining? Here. Alright, let's just rebuild this. Because I'm seeing more errors than I would like. Alright, now they're all gone. Right, cool, this is fine. Right, let's go actually before we continue fix some of these warnings because this is kind of a pain. But this should not be right. So this is why is it complaining? It's not true in this call, right? So we're waiting for the expression 0 is less than param 1. Yeah, it's not true in this call. So we can just do hashtag pragma warning, and I think ignore. Was this a syntax? I think so. And pragma warning. Oh, what did I copy? I copied something I didn't want to copy. Oh, no, I didn't. Right. No, the ignore syntax is definitely wrong. Let me double check real quick what that was. MSVC, pragma ignore warning. I always forget what the Oh right, I'm pretty close. So pragma warning, disable. I think it was like this. And then 2A 020. Right. I think that should run. So we have 24 now, and we should go down now, right? Errorless. Yeah, 15. Okay, that's right. Yeah, and then hashtag include pragma warning push 0. And this is the arithmetic one. And we can just ignore this one. That's fine. Because it's basically complaining that we're costing an 8-byte value to a 4-byte value. Or sorry, multiplication on a 4-byte value then cost the result. But no, thank you. I don't want to become famous, or at least not with that link. Sorry, man. But yeah, we're basically doing maths that officially can create a floating point overflow and stuff. But we're gonna need a model with so many vertices that at that point we have bigger problems to worry about than the overflow. So simply ignoring that will be completely fine. Why are we still Visual Studio? Why are we still complaining about here? Right, whatever. Yeah, unref is formal parameter, current depth, yeah, sure. Actually, we can simply do this real quick. So if current depth equals greater or equal than, let's define this here. No, let's actually make it, oh, we already have the value. Then max depth, return empty. Cool. So we fixed that. Right, so this one equals, I think it's complaining, but no, it's not from t to int. Right. So by simply casting these, we can get rid of that warning. And same here. Right. I think now we should get rid of most warnings, except these for some magical reason, and this one still. Why is it back? Let's do a rebuild, because it specifically said ignore the warning. Like you're not ignoring the warning. Why are we getting more now? Why are you giving me more Visual Studio? Oh, right. I think I know why. So I do actually need this, I think. Right, let's build. Right, now we're getting less. Yeah, there we go. Right, so this is included from type quad. Interesting. Oh, I think it might be from this header. So source core obj loader. Sure. So we can simply do this and then add another one with a comma, I think. Or did I? No, I can just do a space. So 4201. Right, I think this should be fine. Now at least got rid of the warning. Because it was kind of bugging me that we had the huge error list. Or the, sorry, warning list. I couldn't focus on anything else, sorry. But, oh no, I did lose my train of thought on the other one. Right, so where were we? Right, oh yeah, sorry, yeah, binning. I remember what I was doing. Right, binning. Right, so now we subdivided the node into left and right. Now we need to partition. Right. So UN32T pivot, and this equals, so this gives us a UN32T partition, and this takes in the a UN32 let's actually just copy the function definition here. Let me check. So right, so we have first that we need. Then we have UN32 count and a full ref. No, we can't. We can ignore that. Right. So we have the full-on partitioning function. Right, implementation. Right. So this pivot equals partition left and current node dot count. Right. Yeah. So we're passing in the beginning. What is the left one? What's 0 in this case? So we're partitioning object 0 till the number of count. Yeah, sure. Right. Right. Yeah, sorry if I'm a bit quiet. I am thinking quite hard. Oh shit, that's my mill. I don't want to share that. Oh well. Right, I'm just thinking real quick. Right, so we need to partition the objects by splitting the access and calculating the surface area. Cool. Right. So let me think how we can approach this problem. Right. 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 So we need. Right. Okay. Cool. So first of all, we need to define the split axes. What's very simple, we need a for loop with 0, and this is num splits, right? And this can be a uint32. And why is this not okay? Expected. It's a number. Oh, yeah, sorry. This shouldn't be an equals. I forgot how defines work. Right. Now you have an expression. This is... I am stupid as hell sometimes. Right. Right. So for the x-axis, the code would do something like this, right? So we have the... I don't want to pass in the current node. No, I don't have to, because I know the first node that we have to partition. What is node 0? Because we're partitioning a node, right? I'm thinking real hard. I always hated the spatial partitioning stuff because it's an actual mind fuck. Right, so we have the bounding box, right? What is the m.nodes dot so std array of glm factory 2 reference bounds equals m.nodes dot first No, wait, we can't actually do this. No. Because this is the index in the array of objects. But yeah. All right, we can't do that way. Because if I look at the old code, right, the first is basically the object. So this is object in the array of triangles, right? This would be triangle 0, and this would be triangle 30,000. And we need to partition those triangles, so we don't partition nodes. I mean, we do, but, you know. So we need another value here. We need to know the original bounds. So glm, so std array of glm fact 3,2 reference bounds. Right. And then we do need to include array. Right. And then we need to use function definition. I don't need this anymore because we already have the reference, right? So then, I am so bad with this, right? So then we have the split axis that we need to calculate. Right, so we have a glm vec2 split axis, right? Right, so this is split axis. So the x, let's just look at this from the x perspective, right? Oh, we do need to actually pass in the bounds here. So current node dot bounds, right? So if we split along the x-axis, the y is going to simply be No, we actually don't. We don't care. That's actually the nice thing about this, right? No, we simply care about the x-axis because we're just checking if it's left or right of the x-axis. Sure. Right. Right. So we need a float split point. And this is cool. So we're subdividing, right? So we're getting float distance, and this is equal to the bounds 1 minus. I think we could just do no because we just care about the. I think we can just do GLM this distance of bounds dot 0 dot x and bounds bounds dot 1 dot x, right? Right. So this should give us the distance, right? Oh, I think we can actually do the following, right? So we can just simply have an int. Well, let's actually create a small enum here, right? So the enum plus axis. No, let's actually just do an enum. Enum axis, and this is x, y, and z, right? So we have e axis split axis. Right. And then we can simply do another for loop. And this is between 3, so 0, 1, 2. Yeah. And then we can use the 3. And then we can use the fact that we can implicitly cast enums or integers to enums. So we can simply say, oh, sorry, I do need axis, right? Axis, and then simply axis, right? Yeah, so this works. And then splitting axis equals and I do think we need to actually cast this. I thought this worked. Assigned values never used. Why is it complaining? I thought we could. Is it just inside ints then? I thought you could initialize enums with integers. Pretty sure that works in C. Wait, do I need to set this equal to 0 then? Just so it knows what the. Right, cool. I mean, we can simply do the following. We can just cost it. Axis, right? Sure, whatever. And I was complaining, you said it cost. Sure, there we go. So now we can actually do the operation for all 3 axes in an agnostic matter. So we now know the split axis that we're working on, although we probably need some sort of way to actually figure out which axis we actually want to split on and the point. Cool. Right. Oh, right. So this should actually be the other way around. I'm just noticing. Because we do each operation for each axis, not 16 times for each axis. Right. And this should be only done once. Same with this. So this should be outside of that loop, right? So, and then we have another increment float inc, and this is equal to distance divided by num of splits, right? Yeah. So now we say we can increment, can increment the distance. So we divide the distance by number of splits, and that gives us an increment that we can check against for the binning, right? And then the start is just 0 plus increment, and then we just keep going, right? Do we check? Yeah, we start with the plus the increment, right? Yeah, sure. So then we now have these values. Cool. Yes. Sorry. It's really hard to focus on these kind of things because it's quite a hard problem. Because it's really hard to visualize in my head what I actually want to do. But we're getting there. So now the uh, right, so we have a flow. We have a float that's current split point, and this is equal to bounds 0 dot axis plus I plus 1. Now I can simply say I is 1 plus I times num of increments times inc, right? Yeah, cool. So now this gives us a actual split point. Now we subdivide the objects that we have. Okay, we're getting somewhere. Slowly but surely. Right. So we need to subdivide the objects. Although I think we can simply use pointers to the objects. Well, in this case, they're just simply triangles, right? Alright. I mean, there's nothing stopping us from simply rearranging the triangles in the array. I don't see. Yeah, we can simply do that. I don't see the problem with that. Yeah, we can simply swap them. Yeah, we can literally just sort them. We can actually use an std sort with a simple lambda that yeah, we can definitely do that. Yeah, we can. Right, so we do need to pass in the. So what, instead of this, we pass in the node. No, we need to pass in the triangles. So we pass in a. No, we can't actually make this a constant reference here. Because we actually are going to modify the model. Yeah, we're going to modify the model. So this takes in the RT model. But then we don't need the bounds here. No, we do need the bounds here. Right. So we're passing in the model we actually want to partition. Very cool. And then here we pass in model. Oh. No, we call the partition from the subdivide. Right, so you're subdividing the model, right? So we need it in the subdivide as well. And then model. And then model. Right, cool. So now we know the model, right? So then we can do an std source. I think it's an algorithm, right? To include algorithm. So std sort. So then we do model dot triangles dot begin plus first, comma models dot triangles dot end. No, dot begin plus first plus count, right? And then we need a lambda. What is this? This. Right. std sort with lambda. Let me double check the syntax for this. std sort with lambda. All right. So this takes in a const RT triangle reference A and then a const RT triangle B. Right. Next, we do actually need to pass something in. We need to pass in the split axis. We can simply pass that in. We can just pass the value and split point. Right. Although, yeah, split axis and split point. Cool. Sure. That's all the info we need, right? And then I think let me double check, right? All right, so we need to define basically greater than less or 0, right? So if do I need? Yeah, right. So what are we sorting it on? We're sorting it on. Yeah, right. This is very simple. So if a dot. Wait, why can I not access the underlying vertices? Do I not have? No, of course not. Of course I can't access the vertices. Why would I be able to? That would be too convenient, right? Oh no. I had the CAD center, right. I remember. I'm being dumb. So if a dot. What is a CAD center? Why can I not do the get center game or engine? There's literally a get center here. Can we? Okay, fine, sure. Stick include gore / triangle. Fine. You win game. You win Visual Studio. I'm going to include the triangle. Are we now going to allow me to do get? Is it with a capital? Right. The split axis, right? Equals. Oh no, we can actually. I think we could just make this a one-liner. Return a dot get center dot split axis is less than b dot get center dot split axis. Oh, I know why we. Yeah, right. This function is marked as const, right? Cool. Although I think I can actually simply do. No. Can I make. No, okay, I can't here. Right, of course that doesn't work. Get center, and this is a const function, right? Right, so for everybody new to the stream, we're working on creating a bounding volume hierarchy for the Raytracer. And it's still very, very early in the process because I'm really bad at creating a BVH. It takes a lot of mental capacity to create it. But basically this is let me show you the progress that we working on. So yeah. Raytracer.cpp. Can I just do? No, it's defined in here, right? So, because I kind of want to call. So I think I could just do I could just do BVH. No, let's just include the BVH here so we can test it. Hashtag include gore slash BVH, right? So we have a BV or RT BVH, BVH, and this is equal to model. This is not okay since this is a unique pointer. Can we? Yeah, I pass in. Can we? Is there just like just get. Why can we not? I mean, this should be fine, right? Why are we complaining here? Sure. I think that should be fine, right? Oh, do you need to dereference this or? That's interesting. Because we have one for. This is just a unique pointer. I mean, there's. I mean, sure, let's just. Can I do now RTBVH though? Right, what if I instead do something different, right? And have it pass in a unique pointer. No, but a reference should be fine. Right, look. Right. Yeah, I should be able to just dereference it. That doesn't see the problem. RTBVH, BVH. Right. So why are we still complaining? Conversion of the first argument at models ill formed cannot convert the R value of ST unique pointer to parameter type RT. All right. So what is this defined as? Are you trying to cast? Is it trying to do it as a second function? Maybe. All right. Let's see what. Are you happy now? RT. Why is it? Why does it want to be const? Huh? Right. So, okay, this is interesting. So it's trying to call the move or copy constructor, I think, of the BVH. What is interesting, because we specifically say that we want a model. Sorry, in here, BVH. Because we specifically have. Oh! Right. I'm doing something very stupid, right? So we construct the BVH, but. Right, that's actually stupid. Yeah, okay, sorry. This is actually my bad. So we have RT, BVH, right? Sure. And then let's actually make a non-default constructor for now, simply so we can create the BVH. So, can I generate implementation? There we go. So, BVH.build BVH model, and then we do need to dereference it. Right. Why did this take me so long to figure out? Right. Raytracer BV8. Right. So this should trigger if we go to debug, right? So if I didn't mess up anything, I messed up something cool. Oh, right. Yeah, we do need to return something. It doesn't really matter what. Right, so if we now look at the triangles, right? So the split axis equals 0, right? Yeah. So they should now all be sorted on the x-axis. So this is no. Okay, that's lovely. That did exactly not what it should do. Although maybe I put the breakpoint in the wrong position. Right. Let's just put it on the sword, and then just step over it just to be sure. Step over. Right. No. Right. So the split axis is 0. Okay. Split point is 0. Oh, right. No, we don't actually need this one. We just need the the split axis, right? Or should it be greater than, right, for the STD sort? Right, because I don't use the STD sort predicate that much. I think I think it should be greater than, actually, right? I think it needs to note that, right? And the breakpoint here should be fine, right? So hopefully now we should have a sorted array for the models. Right, triangles. Yeah, there we go. That looks different. Right, 0.01. Does this sound correct? No, this sounds absolutely wrong. Because they should be in either ascending or descending order. Oh, wait. Yeah, right. So I did an oopsie. I was looking at the normal, not the vertices. Oh, right. Yeah. Of course, I can't check this right this way because this is a very naive approach of checking things. Right. Yeah. So we're getting the center of the triangle, and then returning if it's greater than or less than. But yeah, we can't simply just compare the values like that because that doesn't make sense. Because we don't know the center; it's not stored, so we can't just simply see the ordering. What is a very simple overshot of me. But this should work, so I'm just going to believe it works. Yeah, cool. I'm sure that works. So if I'm correct, this should order them from small to big. So it should take the smallest. Right, no, so this returns 1 if it's greater than. Might have to be the other way around. Well, we can see. Right. I mean, I don't think it really matters anyway. Because we're just splitting along one of the two anyway, so well, either result is fine. Cool. So we now have the partition. Now we need to find out where the split point is. Right. So we now have we now sorted all the shapes that we care about. And then we need to split the shapes. Yeah, not split them, sorry. We need to check which shapes on the left and on the right, where the actual pivot is. And then we need to calculate the area. Okay. We're getting there. Right, so then for E, so there should be 0. No, we can actually just do the following. We can just do first, and this is first plus count. And we can just call this triangle. Right. Hello there. Thank you for joining the stream. If you have any questions, do feel free to ask. So, short update what I'm working on. Right. So I've been building a Raytracer, and I absolutely hate making spatial partitioning because it is an absolute mindfuck. But we're getting there. The basic idea is very, very simple. Spatial partitioning, we basically subdivide all objects into boxes, and that way we can basically see which boxes we intersect, and every time drop 50% of the shapes. So the 5,000 shapes should theoretically become about 15 intersections. Wait, it is? That's interesting. Wait, let me check my audio. Because right. Sorry. Let me see if I can fix that for you. I mean, it could simply be I'm mumbling what I actually do tend to do when I'm focused. Alright, so I'll try to pronounce things a bit better. Hopefully the audio doesn't cut me out that way. Although if it keeps cutting out, just let me know, because then I can try just setting the input to the... No, I could just try that as well. So I'm using RTX voice to make the audio a bit better, so it filters out background noise. However, it might simply be complaining, or it might not like my voice and just filter out my voice. What have actually happened before, what is kind of stupid. Right, so let me fix this real quick. So now it's using my mic directly, I believe. So there might be a bit more background noise, but it shouldn't cut out, at least. Wait, okay, yeah, sure. Right, is it still cutting out my voice? Right, is this better now, or no, we're running away. Let me actually debug. Right. Right, so let's see. Is my voice still cutting out? Ah, okay, great. Right, sorry about that. I don't know, why is it... Wait, is it only in when I'm debugging that my voice cuts out? Because that would be really, really odd. Because I don't see a reason why it would do that. That would be so weird. Right, where was it? Right, so split point, right. So we need to know the pivots. So UN32 pivots. What we can initialize to first. Yeah, so if we do need to get the center again. It's kind of wasteful, but whatever, should be fine. Right. So if model dot triangles dot first. That's right. It should be just triangle. Dot get center axis is less than current split point, then pivot plus plus. Sorry, so you can do less or equal then, right? And else rebreak. No, we can actually set it to 0. I think that's a bit more logical. So, right. So this should basically go over the models that we just sorted and basically say the center. So if the center is left of the split point, it will move the pivot along, and the actual moment that we that this condition isn't true anymore, it means that all the other things are on the right of the split point, so we can break, because it's already sorted, right? So now, if you run this, hopefully it should give us a sensical value. Right. So can I see pivot? Visual Studio? No. Okay. Oh, I did put the breakpoint on the wrong. No, it should be. Just let me add this to the watch. Right. Oh, maybe I put it in the... Right, sure. Wait, we're now not hitting the breakpoint anymore? Sometimes I hate Visual Studio. Right, cool. So step over, step out, step over. So this is right. So what does this evaluate? Oh, step out. Step out. Right, it immediately breaks. Right, did I? Right, so let's see what happens if I change the predicate here. Does this now actually give me? Right, yeah, okay. So I ordered these shapes the wrong way around. So, small issue on my part. Right, so here, pivot. We can still not re-pivot. Of course we can't. Let's just print pivot. Printf %d /n. And let's just run this code, because now this should give us a bunch of pivot information. So I'm kind of curious what this does in general. Right. Those are some interesting values. That's actually interesting. Because this should be... Right, so this is just the first shape. Right. Okay. No, these values make sense. Right. Although... Did they? Right. Oh, yeah, right. So we should... The first 16 values are X, then Y, and then Z, right? So we can see that on the... I think this is Y. No, sorry, this is Z. So you can see on this first increment, there's not a lot on the Z. Right. No, okay. Right, this makes sense. I think this could be about right. And on the very end, we can see this is approaching, because theoretically on the most right turn split axis, or the binning position, basically everything should be on the left. Right. Who's pinging me on Discord? Right. No, this actually seems to be correct. Cool. So now, what we need to do, right? So now we have the ability to find all the objects what are on left and the right. So now we actually need to calculate the surface area of all the possibilities, and then find the minimum surface area. That will be our best position. So where am I using this split axis, right? So let me actually promote this to this one, right? And split point, I'm not using it, right? Cool. Do I need this? Maybe. And then we have E axis, and this is actually the final axis. And this is the final split point. Right. Final axis, right. So now we know this pivot. So let me actually comment this code, right? So sort the objects based on the provided split axis. Then we find the pivot point. So then we know the pivot point. Then we need to calculate the surface area, right? So I need to know the bounding box of all the triangles in here. So did the model.triangles.0, do I have a... No, I don't have a get bounds, right? Because we need the ability to create bounds around a bunch of triangles. But we can create a simple helper function for that. Because we would create two bounds, calculate their surface area, and check if it's less than what we currently have. So we need a value here for surface area as well. Float surface area. And this is equal to infinity at the start, right? Oh, I actually do notice something else here. I do think I actually have to cut the stream here because I'm becoming a blood donor and I have my appointment at 1 for donating blood. So, sorry, not at 1, at 1:20. So that's in 20 minutes and it's like a 5-minute drive. So I need to prepare for that. But yeah, no, I think we definitely made some good progress with the BVH. It's always a slow process. It's quite hard to wrap my head around, especially because you can't really test most of it till it's done. You can only kind of see the numbers and see if it makes sense or not. But once it works, we should see from like 4 seconds per frame to like 30, 60 FPS. What would be amazing, because then we can create actual scenes with like tens of models, like hundreds of models, and still have decent FPS. That would be really cool. But anyway, thank you guys for watching, and hopefully I will stream soon again. Have a nice day.